Kiro is an AI-powered IDE that brings engineering rigor to agentic development by turning plain language ideas into structured requirements, designs, and implementation plans before any code is generated. Unlike typical AI coding assistants that simply react to prompts and emit code, Kiro enforces spec-driven development by making intent explicit, tying tasks to acceptance criteria and dependencies, and keeping implementation continuously aligned with a living spec. I asked Kiro to build a Tetris game implementation in 3 different development modes. 2 of them are structured spec-driven development modes, while the third is using vibe mode, which is similar to how other AI coding assistants work. The 2 structured modes produced more code, more bulk, and more unwanted planning document artifacts in the code than the unstructured one. Here's what happened. Kiro offers 3 feature development modes. 2 spec mode variants, requirements first and design first, generate planning markdown before any code is written. Vibe mode skips all that and goes straight from prompt to code. Kiro's docs say to use spec mode for complex features and vibe mode for quick prototypes. I tested whether that holds when you already have a detailed spec. I held everything constant except the authoring mode. Same model, Opus 4.6, in all 3 runs. Same detailed requirements document for a Tetris game with gravity, level progression, a heuristic autoplay, and config persistence. I gave vibe mode the same comprehensive spec the spec mode runs got. All 3 implementations passed the same functional tests. The output artifacts are 3 single-file vanilla JavaScript implementations of the same thing. I reviewed each line by line and scored them on 13 code quality dimensions, then ran a quantitative static analysis pass with 28 metrics for cross-checking. The 13 dimensions cover formatting, readability, layering, naming, function length, persistence handling, magic numbers, and others. The 28 quantitative metrics cover line counts, ESLint warnings, AST-derived cyclomatic complexity, function length statistics, and DOM call counts. 2 scoring axes, one based on judgment, one based on hard numbers. So my qualitative opinions could be cross-checked against what the static analysis tools said. Out of 13 qualitative dimensions, vibe mode took 8. The 2 spec mode variants combined for 4. On the quantitative side, the split was similar. Vibe 16, spec 8 between them. Vibe sweeps the file level concerns. Bulk, layering, naming, function length, async. Spec mode wins on narrow per feature axes, persistence validation, and magic number hoisting. The pattern is consistent across both review methods. First, spec mode writes more code to do the same thing. Requirements first clocked in at 2,382 lines of HTML. Design first at 2,139. Vibe mode did the same job in 1,319. 45% smaller than requirements first and 38% smaller than design first. Requirements first is worst on 6 independent bulk metrics, including longest function at 122 lines and 10 functions over 50 lines. It's an even thickening across the whole code. Second, spec mode's planning artifacts leak into the source. Both spec runs generate a task's markdown file. In design first, the task IDs ship as section banner comments in the code itself. Vibe mode's banners are named by what the code does. The planning doc is supposed to be intermediate. In spec mode, it stays in the production source. The shape of the planning doc shapes the code. Requirements first's task plan lists the AI's 5 tuning weights as 5 sub-bullets. And Kiro then produces 5 parallel scalar globals in code, where 1 config object would do. Adding a 6th weight in vibe mode is a 1-line change. In requirements first, it's 4 coordinated edits across the file. The same pattern hits HTML structure. The task plan's instruction, 10 by 20 grid of div cells, becomes 200 literal div tags inlined in the generated code. Vibe mode produces the same 200 cells from a 6-line code loop. The planning prose became the code's structure, almost word for word. When tasks bundle concerns, the resulting functions bundle them too. Requirements first's task plan combines line clearing, scoring, level tracking, and game over check into one task. And the resultant generated code becomes a 56-line lock piece function with all of that fused inline. Design first splits the same concerns across 4 tasks and produces 4 separate tight functions. The bottom-up build order leaves a different fossil. Requirements first wraps every cross-task function call in a type of equals function guard, 22 of them, even when the called function is defined directly above it in the same script block. Vibe mode just calls the functions directly, 0 unnecessary guards. But Spec Mode wasn't useless. 3 places it actually came out ahead. First, persistence validation. Design first is the only mode that bounds checks what it loads from local storage. Every stored weight is parse floated and checked against its declared range, with per key fallback to defaults. Vibe mode just returns JSON.parse raw. A tampered or version-skewed payload can load garbage into game state. An out-of-range weight passes the type of check unchallenged, and a missing key leaves a stale module init value. This isn't an emergent property of the code generator. Design first's design spec prescribes range validation directly. The design artifact asked for it. The generator delivered a near verbatim translation. Second, per function discipline. Both spec modes produce a meaningfully tamer worst-case function. Max cyclomatic complexity of 29 for design first, 30 for requirements first, against Vibe mode's 42. The single gnarliest function in Vibe's output is notably more branchy than the worst function in either spec run. The design specs show why. Design first's design file specifies each core function with explicit preconditions, postconditions, and loop invariants before any code is generated. The mode that puts more per function specification into its design document produces the tightest per function code. Third, magic numbers. Requirements first has the fewest no magic numbers lint warnings, 41 against Vibe mode's 55. The mechanism is in the task plan. Requirements first has a dedicated defined constant step that prescribes the scoring table, wall kick offsets, and level progression thresholds before any implementation task runs. That upfront constants hoisting instruction is what Vibe mode's prompt-only workflow lacks. Worth noting what didn't change across the 3 modes. None use strict mode, none declared CSS custom properties, none reached for classes or ES modules, none addressed accessibility. All 3 are single-file vanilla JavaScript artifacts with the same rough architectural shape. The mode switch didn't induce structurally different choices. What changed was how much of the planning pipeline's own structure leaked into the code. Task IDs, scalar enumerations, defensive guards, literal grids. Here are 3 caveats. Vibe mode got the same detailed spec as the spec runs. This is a same spec different pipeline comparison, not structured versus unstructured prompting. I ran Kiro with defaults. I didn't iterate the intermediate artifacts. And I didn't exercise Spec Mode's property-based testing, which can auto-generate hundreds of randomized tests from ears format requirements. Both spec runs defined 17 property test tasks. I skipped them all. That's a real benefit my code quality review doesn't capture. Finally, here's a practical takeaway. If you already have a detailed spec, feed it to Vibe mode rather than Spec Mode, even though Kiro's docs steer you the other way. If you do reach for Spec Mode, prefer design first. Hand Kiro your architectural intent as a design spec, function contracts, loop invariants, error handling, and it lands in the code roughly as written. If you find technical content like this insightful, be sure to hit that like button so I know to make more of these. And make sure to subscribe to this channel so you don't miss the next video. The full write-up for this experiment is linked in the description. Go check it out.